This is the planet Mars, as seen from Earth across millions of miles. Hazy, shifting, a difficult object to draw, photograph, or study. But through the centuries, astronomers developed ingenious techniques to surmount these difficulties. They charted the features on the surface of Mars, tracked huge dust storms sweeping across its surface, and studied the polar caps as they shrank and then grew again. Some astronomers thought they saw canals on Mars, which they interpreted as evidence of an intelligent life form. Man began to think of Mars as almost a twin to Earth. Then, in 1965, the unmanned spacecraft Mariner 4 flew past Mars 6,000 miles above its surface. Its single camera took photographs that were startling, showing a cratered surface resembling that of our moon and not the Earth. But Mariner 4 was only the first step in exploring Mars with unmanned spacecraft. In 1969, the larger and more complex Mariners 6 and 7 were sent to Mars by the National Aeronautics and Space Administration. These spacecraft carried new scientific instruments to probe the atmosphere and measure temperatures on the surface, and 2 cameras to photograph the planet. They could gather 1,600 times the information collected by Mariner 4 and transmit it to Earth 2,000 times faster. Responsibility for the second flight to Mars was again assigned to the Jet Propulsion Laboratory of the California Institute of Technology. The mission was called Mariner Mars 69. The spacecraft itself is intricate, carefully designed, microscopically inspected, almost jewel-like in its perfection. Robots built by man that can endure the deep cold of space, exist in a vacuum, withstand the unshielded radiation of the sun, designed to travel hundreds of millions of miles in space, equipped with cameras to give them eyes sharper than man's, and with instruments that can see where man cannot. The instruments and cameras they carried were mounted on a movable platform so they could be accurately pointed at specific areas on Mars as the spacecraft flew past the planet. The men responsible for the instruments: Dr. Charles Barth of the University of Colorado. The object of his experiment: analyze the upper atmosphere of Mars. The lower atmosphere of Mars to be studied by a University of California scientist, Dr. George Pimentel. Temperatures on the surface of Mars to be measured by Dr. Gary Neugebauer of the California Institute of Technology. The photography of Mars was to be the responsibility of Dr. Robert Layton, also of the California Institute of Technology. He led the scientific team that provided the first pictures of Mars in 1965 with 1 camera. In 1969, his team had 2 cameras, one fitted with a special telescope that gave it 10 times the power of the camera on Mariner 4. Dr. Arvidas Kleor of the Jet Propulsion Laboratory. His experiment: determining atmospheric pressure on Mars. Dr. John Anderson of the Jet Propulsion Laboratory would analyze tracking data to refine our knowledge of the mass of Mars and its precise orbit around the Sun. To learn about Mars, the scientists would examine its smallest parts, its molecules and its atoms. Their scientific instruments were equipped with detectors sensitive to radiation in various wavelengths. Molecules and atoms absorb the energy of sunlight, or absorb and then re-radiate that energy in specific wavelengths that are signatures of the type of molecule or atom. By identifying a molecule or atom, the instrument can then detect the presence of various gases or dust in the Mars atmosphere. Temperatures on the surface are determined by measuring radiation in the infrared wavelengths from atoms and molecules. And of course, photography itself is simply the recording of radiation in the visible wavelength. Dr. Barth's instrument would record radiation in ultraviolet wavelengths to identify gases in the upper atmosphere. In the lower atmosphere, Dr. Pimentel would record infrared radiation to identify gases and seek evidence of the materials on the surface. Dr. Neugebauer's instrument would record surface temperatures by measuring infrared radiation. He would measure temperatures at the south pole of Mars, hopefully to determine if it were covered with frozen water, frozen carbon dioxide, or a mixture of both. He would also make measurements on the night side of Mars, the side that cannot be seen from Earth. At Mars, the instruments would sweep across the planet in broad strokes as the spacecraft flew past. This is the field of view of the upper atmosphere experiment, the ultraviolet spectrometer. Its scan path would begin in the atmosphere and then move across the planet. The infrared spectrometer scan to analyze the lower atmosphere. These points represent the infrared radiometer measurement to record temperatures. The cameras on each spacecraft would photograph the surface, with the narrow-angle pictures falling inside the overlapping wide-angle pictures. Temperature measurements fall inside of the photographs, allowing correlation of changes in temperatures with surface features. Determining pressures in the Martian atmosphere is vital to understanding wind patterns and interpreting other information, like temperatures. Dr. Cleore's experiment is performed by transmitting radio signals to Earth through the atmosphere of Mars. The distortion of the signal by the atmosphere yields pressure measurements at various altitudes. It was now late July, and the Mariners were ending their 200-million-mile journey and were approaching Mars. It was time for Mariner 6 to go to work. Its instruments had been turned on by commands from the spacecraft's computer. This was the crucial time for hundreds of scientists, engineers, and technicians. And suddenly Mariner 7's radio signal was lost, flickered on, and faded again. The loss of 7 would be staggering. A special team of engineers was quickly formed to investigate, to determine if there was any chance for 7. The majority of the mission team was concentrating on Mariner 6, but no one could forget Mariner 7 for a moment. A faint, intermittent signal could be heard from 7. It appeared to the investigation team that the spacecraft was rolling, and therefore its transmitting antenna was not pointed at Earth. What started the spacecraft rolling was unknown. The stations of the Deep Space Network called in extra personnel and began the task of re-establishing radio contact. The Canberra station in Australia locked onto the spacecraft signal and then sent a command that would stop it from rolling. The faint, intermittent signal from Mariner 7 steadied and increased in strength. The rolling had stopped, and its antenna again pointed at Earth. A thorough checkout by radio revealed that it was in working order. Although some engineering measurements on the spacecraft had been lost, Mariner 7 was in shape for its encounter with Mars. But now an unexpected failure on Mariner 6. A cooling system for Dr. Pimentel's lower atmosphere experiment failed. That meant that one of the detectors in the instrument could not work. Pimentel would get only half the information he wanted. It was a bitter disappointment. But the other detector, not requiring a special cooling system, did work. And 5 days behind 6 was Mariner 7, a second chance for Pimentel to get his data. As Mars rotated in view of the approaching Mariner 6, scientists saw the familiar features observed so often from Earth. And for the first time, they saw the southern polar cap of Mars as jagged and uneven, not as a smooth area of white as it is usually seen from Earth. This the scientists had to investigate. To do so, Mariner 7's program would be changed to concentrate on the South Pole. As Mariner 6 closed on Mars, the large, dark, apparently sharp features seen from Earth became diffused and blotchy in appearance. Later, some prominent features and some so-called canals would resolve themselves into groups of craters. On completion of the approach pictures, the spacecraft swept past Mars with cameras and instruments now trained on certain special areas. After Mariner 4 in 1965, Mars had been described as moon-like. The first group of new photographs taken by the cameras of Mariner 6 revealed to the scientists that Mars had some surface features quite unlike the moon. Here is a flat plain, a large old crater, and unexpectedly, a broken, jumbled, uncratered area. The scientists call it chaotic terrain. Similar terrain is known on Earth, but not covering thousands of square miles. Another photo reveals more chaotic terrain sunken into the Martian surface. Cause? Unknown. It could be caused by melting of underground ice, which some scientists believe could be there. Another possible explanation is the collapse of underground caverns formed by volcanic action. But that presumes that Mars has a history that includes substantial volcanic activity, and scientists find little external evidence of such a history. Mariner 6 photographed a 2,500-mile-long strip on the Martian equator in a series of wide-angle pictures. The permanent feature Meridiani Sinus is shown here. A narrow-angle picture within that strip showing the two types of craters observed on Mars. Large, flat-bottomed ancient ones, and small, bowl-shaped new ones. The smallest craters here are 1,000 feet in diameter. The largest is 24 miles across. The sides of this picture are 63 miles by 48 miles. The crater in the rim has a central peak similar to some moon craters. The smaller craters are younger than the large ones and have apparently not been greatly eroded. However, all features give the impression of being blanketed by layers of fine wind-blown sand or dust. This blanketing is yet to be explained. The walls on the west side of this crater have slumped, while the southern wall is cut by gullies. Southwest of the large crater is a broad trough, similar to features seen on the moon. This photo was taken at 3:30 in the afternoon, Martian time. The temperature at noon on the equator, reported by Dr. Neugebauer, 62 degrees Fahrenheit, one of 3,000 temperature measurements he obtained. At about 5 p.m. Martian time, the cameras recorded a large 150-mile diameter crater. On its rim, a 15-mile diameter crater, flat-bottomed and containing a newer dish-shaped crater. The picture track continues on into darkness. Although the cameras could no longer see, the other instruments could. Temperatures recorded on the night side of Mars fell as low as minus 100 degrees Fahrenheit. Mariner 6 has surprised scientists with its photographs of chaotic terrain. Mariner 7 photographs would also hold a surprise that would also pose new questions. In the southern hemisphere of Mars is a light-colored circular feature known as Hellas. To the west is Hellespontus. Mariner 7 photographed this area. The Hellespontus region is heavily cratered and bordered by ridges that mark the boundary between the two regions. Dr. Cleor reported that the atmospheric pressure at the surface of Hellespontus was much lower than the Martian average. The lower pressure indicates that Hellespontus is an elevated plateau, measuring about 60 miles across and standing 2 to 3 miles above the surrounding area. Dr. Pimentel's infrared spectrometer, in analyzing the lower atmosphere, also showed a substantial drop in elevation between Hellespontus and Hellas. From the ridges bordering Hellespontus, the camera scanned into the bright region of Hellas to reveal a sudden and startling lack of craters. Not a single crater is seen over a distance of more than 1,000 miles. Even at 10 times the magnification of the wide-angle camera, no craters were visible in Hellas. It is not possible that Hellas could have escaped the bombardment that has cratered the surface of Mars. Therefore, some process has obliterated the craters, leaving Hellas apparently as smooth as a dry lake bed on Earth. Erosion by water could be an explanation. But Mars, according to scientific evidence, has never had sufficient water for erosion. So science must look elsewhere to explain the wiping out of hundreds, perhaps thousands of craters. A plausible answer is high winds, scouring the surface with fine particles of sand. It is believed that high winds exist on Mars, but are there particles light enough to be moved, but too heavy to be blown completely away? And why should this be limited just to this region in the photograph? A mystery, with as yet no answer. The featureless Hellas region was contrasted sharply by the photography of the Martian South Pole. A computer technique that changes contrast brings out more detail in the photograph. The familiar craters were now lightly frosted with frozen water or frozen carbon dioxide. Astronomers studying the Martian poles from Earth had believed the snow caps to be extremely thin, more like a very heavy frost. These photographs indicate there might be drifts of snow several feet thick. These streaks could be drifts of snow or snow-covered ridges. At the first look, they also had suggested clouds. The edge of the cap. Temperature, minus 45 degrees Fahrenheit. Of prime importance in this mission to Mars was to determine if the polar snow was water or carbon dioxide. Dr. Pimentel recorded solid carbon dioxide, but at first thought this could be a cloud suspended over the poles. Later, he determined that the carbon dioxide was on the surface, and he believed it to be a fraction of an inch thick. The temperatures calculated from his data agreed with the temperatures measured by Dr. Neugebauer, almost 200 degrees below zero. Correlating their information with Dr. Cleore's pressure estimates for the pole, it was tentatively agreed that the cap is mainly frozen carbon dioxide, with possibly a thin deposit of frozen water. It is not surprising to find frozen carbon dioxide on Mars, as its atmosphere, as estimated from Earth and confirmed by Dr. Barth, is composed mainly of carbon dioxide, unlike our atmosphere, which is composed mainly of nitrogen. The absence of any large amount of nitrogen in the Mars atmosphere, as reported by Dr. Barth, is an important scientific finding because it indicates a past history quite unlike that of Earth. Mariner 4 provided a broad picture of Mars. Mariners 6 and 7 have begun the task of filling in details. In 1971, 2 mariners will orbit Mars to provide still more information. But these future missions to Mars will have a textbook to work from, written by the earlier flights. Textbooks to give them answers to specific problems of spacecraft design, and to suggest new questions to ask with their instruments. The information gleaned from the 1969 Mariner mission supports scientific opinion that Mars is dry and cold with scarcely any water, to man, an inhospitable planet, to any Earth form of life, a difficult planet on which to survive. But despite the bleak picture, scientists cannot rule out the possibility of life on Mars, which the unmanned lander Viking will seek in 1975.